Welcome to Study Loop.
In this problem, we take a look at an equilibrium that has two species on each side. We are going to make an ice table to try to calculate some equilibrium concentrations. We are told that the starting concentrations of our reactants are each 1.5 mole divided by 3 liters. And that we do not have any starting concentration of the other two. To allow the reaction to go, we will lose some of our reactants and gain some of our products. 1.5 divided by 3 is 0.5, so at equilibrium we have 0.5 moles minus X for both of our reactants, and we have X moles of each of our products. Now let's look at the equilibrium expression, Kc. That's going to be equal to concentration of products over concentrations of reactants that equals X squared over 0.5 minus X squared, plugging in from our equilibrium column up here, equilibrium row. We can FOIL this out. And when we multiply out that squared, we get 0.25 minus X plus X squared. We know the value for Kc as well. So now I'm going to multiply this denominator over to this right-hand side. Which will allow me to distribute the numbers. Now to use the quadratic equation, I have to set this equal to 0. So I subtract over my x squared term, get 0.198 x squared plus 0.802 x minus 0.2005 equals 0. I can now do the quadratic equation. X equals negative b, which is 0.802. Ordinarily, the quadratic equation is plus or minus the square root, but here we're just going to do plus because we know we have to have a positive concentration, and b itself here has a minus sign in front of it. It's the square root of b squared minus 4 times a is also 0.802 times c, a is actually 0.198 times negative 0.2005 all over 2a. When you do that, type that into your calculator and you will find x equals 0.236 molar. So that's the final concentrations of CO and H2O, since they are both just X in our equilibrium row over here. calculate the other two, we take 0.5 minus x. That gives us 0.264 molar. So that's the concentrations of CO2